Hi guys, welcome to TEC-X. Today we are starting a new series on Flutter Generative Art. So this series will not targeted for the beginners or intermediate, like this can any level of Flutter programmer or any level of if you don't have any experience with Flutter yet, so you can join this series. This will be for beginners to advanced programmers also. So we will start building a generative art in Flutter from scratch, and then we will figure it out how to build a generative art. So this series will be like the Boring Flutter Show, which is discussion between two persons, and one of them explains the thing, and the other persons also takes over explaining a few things, and they collaborate and come up with a solution at the end. This will be a bit different from that. Here there will be like me, who is a bit experienced with Flutter, and another person who won't be that experienced with Flutter. Like he or she won't be having any experience with Flutter at all. So we will be having a discussion and figure out how to build this generative art. To be honest, I also don't know how to build generative art in Flutter. Like I have experience in Flutter, but not with the generative art. So today with us is Soumi Bardhan. So can you introduce yourself a bit?
Yeah, hi everyone. I am Shomi, and my area of interest is deep learning and computer vision, which is completely different from mobile development with Flutter. So, excited to see how this turns out.
Yeah, great. So as you have heard, our domains are totally different. So let's dive into it. So first of all, before getting started, so give for giving you a bit of information about what is generative art. So let me play a small video. You might be knowing Robert Felker if you are into Flutter generative art. So just let me play this video.
When I start a new artwork, it's just an inspiration. You just have a feeling. So between the first idea and the end result, there's just the same feeling. It's not about the visual. I'm not interested in what you see. I'm interested in what you feel. I'm Robert. My everyday job, I'm a Flutter dev and project manager. And I'm also a Flutter artist. Previously, I was kinda locked by the tool. I can do a lot of stuff, but only what the tool permits me. When I found Flutter, it opened a door inside me. Now I can really push further. Generative art is a lot of research, like a lot. It's a lot of failure. It's a lot of failure finding the color, finding the form, understanding the good behavior of light. What's really good with Flutter is the speed of the feedback. It's nearly instant. Currently, artists do not understand the full potential of the tool. When you start Flutter, you start with material design, or you start with the iOS component, and you think this is Flutter, but this is just the tip of the iceberg. Or if you want to push, then you start to enter the Flutter engine. And the Flutter engine is like the jewels of the crown. Each time I start to code, I just feel joy. So some people are painting, some people are cooking. I just do Flutter. I'm fluttering.
So yeah, generative art is actually a lot of research, but we won't be going into all a totally deep dive into generative art, but we will get started today with it. So for say some reference, we have some generative art. This is created by Devin Joshi, and he has created this amazing looking some generative arts here. So we won't be going this far. So like we will get started today and build like some kind of generative art. So let's get started. So first of all, let's create a new Flutter project. Let's name it Generative Art. Let's open it in VS Code. So this is basically the basic counter app which Flutter creates by default. So let's like run it on the iOS simulator. Let me start it up. And, and let it start up, and let's remove these comments because we don't need it for now. Yeah, so it's building. Let's wait for it to run.
Wow, it's taking a lot of time to build.
Yeah, for the first time, it sometimes
Why do I feel
it's
it will run faster on my mine?
yeah, it's also because this video is recording. That's why.
Okay. So how is the art gonna be? Like, you're gonna generate
Yeah,
pages?
like first of all, we will be start by using like a custom painter. So I believe you don't have any idea with that.
Of course.
Yeah, so we will get started like first we will draw some like normal lines and circles with that first with the custom painter, and then after that we will try to figure out how can we build a generative art with that, because Flutter actually gives pixel level like control, so
Okay.
we can like build anything on that, like we can like control any pixel, draw anything on screen as you wish, like using this custom painter.
Nice.
Yeah, so we will try it out. So here you can see the counter app running. So it's
Yeah.
the default Flutter app that is generated. So we don't need this code, so let's remove this part. And Let's name it just home page and remove the title, and let's uh, give it the title as generative art. Okay, so let's create a like a stateless widget, which is like a immutable widget which you can't like refresh if a part of the like if any variable like changes, so you can't refresh the screen in a like a stateless widget. So we will create a stateless widget now and name it the home page. Now let's give a scaffold here. I am now not going much deep into like the basics of Flutter, like because we will be wasting a lot of time there if we I explain all the things. So we will mostly focus on the part of the custom painter and the generative art today. So let's give it a body and a container here. Now let's rebuild it. Okay, so we change this to a stateless way, so we have to reload. Yes, so you can see that we have an empty screen here and we have this debug banner on top. Let's hide that. Yeah, so you can see now we have an empty screen. So now in order to like draw on the screen, we have to define a custom painter. So what you can do is like wrap the container with a custom painter widget, like the custom paint widget,
Okay.
and then this custom paint, if you hover over it, like this takes a painter, a foreground painter. Uh, so for now we will be using the painter, and let's name our painter as my painter. Mm. So there is like I said, there is one foreground painter as well. So the difference between these two are like this normal painter, this actually paints before the children. Like the child is a container, so this actually paints behind that. Like if the container is containing any children, like if a container is having like a text widget here, so this normal painter will like uh, paint behind that. So if we have another like container or any widget on top, like this painter will be hidden. And this foreground painter is the opposite of that, like it paints after the children. So it will paint above the text. So for now we won't be having any child inside the container, so we can use painter, foreground painter, both will be same for us. Now let's create a my painter class, and let's extend it from the custom painter. Custom painter.
This looks like something even I can do.
Yeah, so the custom painter, uh, we have to provide two things here. Like we have to define the paint method and the should repaint method. So the best thing about Flutter is like you can see we inside the VS Code we can see the whole documentation. of that and what methods we have to define. So even you don't have to define it manually. Like if you like hover over this My Painter and click on this yellow bulb or like control dot in Mac or command dot in Windows. So it gives you these options. So here you can see there is a create two missing overrides. If you click on that, it will automatically create these two methods for us. Okay, yeah. Um, so this should repeat method. This method is basically like uh, rebuilds this painter like when a new instance is created of this custom painter, so it rebuilds the screen. So you can see that we have used a stateless widget. I said that before, if we use stateless widgets, we can't refresh the screen.
Yeah.
But this yeah, so this custom painter is like even if we have a stateless widget, this custom painter provides a low level control. So you can like rebuild even if it is a stateless widget. So if you provide like this returns a boolean. So if you provide if you return true here, so this will rebuild every time like this painter uh, we'll be defining a paint object. So as the paint object changes, this widget will be rebuilt. Yeah. So now let's define the like our painter. Mm, so we can create a um, paint object here. Mm, yeah, we can create a paint object and you can see here like the paint objects there are various defaults set to it. So we will be modifying some of them like let's change the color of it. So let's set the color to maybe colors.red and um, let's see what we have here. Yeah, stroke width. So this will be like the width of the paintbrush, you can say, like how much wide the like the paintbrush stroke would be. So let's define it to be like 2. And for now, I think this is okay with the paint. So you can see basically this paint is actually paintbrush. So let me comment here and say paintbrush. And now uh, to get started, let's first draw like a line across the screen. So before that, like to give you a bit of idea how this like canvas works. Mm, just a bit. Let me connect my iPad and show you. Yeah. So let's say we have this screen. Um, Now one more thing, like we have the children over there, like so we have set the children to be like the mic, this container here, just the container with no children inside it. So if you define just a container, is it actually takes up the whole space of the screen. Like this whole space will be taken up by this container. And we have defined the custom paint to uh, like over this container. So this custom paint, like the canvas will be total area of the screen. So we can say that the uh, this top left hand corner, this is the 0 0 coordinate of that, and now the top right hand corner will be the x coordinate will be 0 and the y coordinate will be the width of the screen. And like that, like this bottom right corner will be the width of the screen, and the y-axis will be height of the screen, and this corner will be 0 comma height of the screen. Like in this way this canvas will be there, and if you want to draw a line across the screen, like as I said, so you have to basically like find this coordinate over here. So this would be the x coordinate will be 0 and y coordinate will be the height by 2, and here it will be width and height by 2. So let's try to draw this here on our Flutter app. Yeah, so we have defined the paint. So now um, we will be drawing the line. So in order to draw a line, um, first let's define the points that will be like the start and end points. So you can define it like an offset start point. So this offset actually takes the x and y coordinate. So the start point will be 0 comma the height by 2. So you can get the height from this. uh, Here you can see there is a size object, so you can use this size to get the height of the screen and divide by 2, and like that we'll be defining the endpoint as well. So the endpoint will be size dot width by size dot height by 2. So now we have the start and end points, and now we have to draw a line between it. So in order to draw a line, now you have to use this canvas object. So uh, on the canvas we can use, I think there is a draw line here. Yeah, so we can use draw line, and this takes point 1 and point 2. So point 1 will be the start point 2 will be the end point, and we have passed the paint object. So this should paint the line, I believe. Yeah, so you can see we have drawn a line here across the screen.
Oh, nice.
Yeah, so you can also change the stroke width, as I said. Like if you increase it, the paintbrush size will increase.
What about making it dotted?
I think you can. do it with filter quality. Hmm, stroke with style. No, style is a bit different. Um, I don't know. I don't remember how you can draw a dotted line.
Okay, probably we can't do that.
I think we can draw a dotted like line, uh, like by running a for loop and then dividing the line into segments and draw them. I think that's possible. So let's not go into that. And okay, let me show you one more thing here. Like, mm, let's start it with uh, like a gap in the beginning. Like, let's start it from the let's 20 pixels and end it 20 pixels back. So we will be having a bit of padding in both sides. Okay, this is the X. Yeah, it's all right. Yeah, so you can see this. We have a padding in both sides. This is a
Yeah,
so this is a 20 pixels, and um, yeah. So I want to show you one thing. Like let's increase the stroke width a bit more, and there is a stroke gap here. So this stroke gap can be set to um, you can see this, the ends are now boxed. So if you want to make it rounded, so you can define the stroke cap to round. You can see, I think like we have the rounded edges on the both sides now.
yeah,
Yeah, that's what the stroke cap is for. So now we have drawn a line. Let's try to draw a circle here. Let's remove this part and draw a circle. So for drawing a circle, what you need is uh, what is important in the circle, like the radius of it and the point about which you want to draw, like the center point.
yeah,
So for the center point, we can again define an offset center point. So in order to draw it in the middle of the screen, the coordinate will be the size dot width by 2, size dot height by 2. So this is the center point of the screen.
yeah,
So now if we can draw the circle with again using the canvas object and then calling the draw circle, I guess. Yeah, draw circle. Here you have to pass the center point, radius of it. Let's define it to be 200, and again the paint. Let's reload. Yeah, so we have a big circle over here. We don't want this stroke cap anymore because we are not drawing a line. And you can see that now the circle is filled. So um, if you want to like draw a bordered circle, like not filling it up, for that, what you can do is, yeah, you can use the style method on this. So this style takes painting style. This contains like the fill and the stroke. So if you use the stroke, So this is only the border of the circle.
Hmm.
Yeah. Hmm. So for now, I think we should keep it like normal filled. I guess by now you have a bit of idea like how to draw on the screen. So
Yep.
yeah, so I think we can get started with generative art and see and figure out what we can do over that. Mm,
Yeah, let's get started.
yeah, so let's think about it for a while. Like, um, let's go back to this one. So this generative art, you can see it mostly consists of particles, right?
Yeah.
Like this contains only circles of different sizes and it has form.
These look like parabolas, half parabolas and stuff.
Yeah, actually this is lot complex. Like we won't be going into.
Yeah, the other shapes are really complex, but some are easy, like the purple line,
Yeah, this
like
uh
the three
I think the
lines.
lines are like normal, like what we have drawn it is like drawn
Yeah,
diagonally. And
I think they have filled points inside that like
mm,
family of straight lines.
yeah, um let's do something like that. Like um what I think is this like it is like following a certain formula and placing the points where the path goes and like that it has
Yeah,
formed the pattern. Mm, so to get started, let's try to like build some particles and place it around a circle. Let's start with that first. So for building particles, let's create a file here and call it particles. Let's define a class particles. Let's call it particle. Mm, so we can have some properties here like we can have its size. We can define its color. So for using color, we have to import, let's import Dart UI and
particle is going to be a circle, na?
yeah, it's going to be a circle. So
So I guess radius and instead of size.
yeah, this size will be, uh, yeah, we can take it as the radius, this size. And I don't think we need anything else for now.
Yeah.
Yeah, so let's define this particle somewhere here. Um,
For generative art, we're using Flutter Custom Painter itself, right? Nothing else.
yeah, the custom painter, as I said, like gives you the pixel level control, so you can draw anything over it. It's the best to use
Okay.
custom painter, that's why. Hmm, let's define a list of particle and hmm, first of all, let's make it a stateful widget. Because I am thinking of like animating at the end, so in order to animate you have to use stateful widget, because if we provide animation inside the painter, like how will we control it? So we have to control it outside the painter so that we can control what is being built inside the painter. So
Yeah.
let's convert it to a stateful widget. And now let's define a init method here. Why is not coming? Yeah. So inside the init method, let's generate the particles. So for particles, let's use random size. I guess we can build particles with different sizes in that way. So
Yeah.
I think we can use random int, and let's set the max size to be 20. So this next int will generate, as you can see here, from 0 to the maximum what we have defined, 20, and inclusive of that. Um, okay, the max is exclusive. So from 0 to 19 it will generate. It will generate any random value from 0 to 19. So let's store it in a variable random size. Okay, this will be int. And one more thing we can do here, we can generate particles of different color. So let's randomize the color as well for each particle. So let's create a variable called random color, and here you can create a color from like the RBG, I guess. Yes, ARBG we can use. So this A is basically for transparency. So let's make it fully opaque. It will be 255, and this will be color. And for this RGB, we can generate random values for that. So this, I guess it's integer values. Yeah, so these are integers. Let's generate a few integers here. Random R, and here from 0 to 256, as it is exclusive of that. Random G, random B, and let's pass them over here.
255, I think. Why 256?
Uh, it's exclusive, I guess. It's written here. Zero inclusive to max exclusive.
Max is 255, I guess. Oh, fine. Try it out. Let's see.
I think this is not included. Like it will be from 0 to
255.
255. So 256,
5, yeah.
256 like won't be included. Like this is exclusive of that.
Oh, I see, I see. Okay, yeah.
Yeah, yeah. Mm, yeah, so let's pass them here. Random. Okay, I missed the comma here. Okay, so now we have the random size and the random color. So let's generate particles here. So we can do it inside a for loop. Mm, let's generate 100 particles. Mm, let's define the number of particles here. And now we can just generate the particles. Particle, and this takes the size. Um, okay, so these total things should be inside the for loop as we are generating random value for each object. And here we can pass the random size. I think we have taken double here, so let's make it int size and the color as a random color and store it inside a particle particle object. And we want to like create a lot of particles, so we will be storing them inside the list. So you can use the particles and add them to the list here. Okay, so this should form the particles here. We have defined it inside the init state because we want to generate at the beginning of like this init state will be called as soon as this home page widget builds, and uh, like before the custom painter builds, this init state will be called. So we are generating the particles beforehand, and let's pass them over the my painter object here. Particles inside the my painter. We have to define a variable to store it. It will be list of particles. Let's define a constructor for it. Okay, so we have to I have passed it using the name, so let's mm, define it as the named parameter over here. Like with the curly braces, you can form it as a named parameter. Now it's giving this error because this can't be null. We are running in the Flutter above the Flutter 2, so this supports null safety. So we can't pass a null object here, so we have to make it required. Yeah. So now we have all the errors gone. We have the particles here. So now we have to paint it on the border of the circle. So how should we do that? I guess um, so we have to like figure out how to get each point on the circle, and draw the points and draw over those points on the border of the circle. So for that, you need basic like the trigonometry formula. Like let's go to an article which I have written here. So this has this basic um, like how can we get the points over the circles? Mm, yeah, so here you can see like this is the formula we can use. So in order to get this x and y coordinate, we can um, this is the x part and this is the y and r is the radius. So we can get the x coordinate as r cos theta and y coordinate as r sin theta. Um, so let's do that.
So you want to draw particles on the border of the circle.
Yeah, like we can get these points over here, various points, and draw the particles over that.
Ah, yes.
Yeah, so it will cover the whole circle. Mm, so let me write the calculation over here so it will be easier. For the x coordinate, we can use the radius into x is the cos. Mm, Now, in order to get various points, what we can do is like change this theta. So vary the theta to generate different points. I guess by this we can generate the different points that we need to place on the border of the circle. Mm, so like we have to place the particles over there. So what we can do is um, the particles is a list. So let's run a for each method over here and we will get each particle here, each particle, and for each particle um, let's generate random theta values. Random next double, and this next double actually generates from 0.0 to 1.0, so any values, any decimal values in between. So we can multiply it with the circumference of the circle. So the maximum circumference is 2 pi r. For that, let's uh, uh, like initialize import this math as math so that we can like easily use them. Like we want to use math.py, so this makes it a lot easier to use that. Like pi can be in different classes, so in order to like not have that conflict, so we can use a math object for that. And so as the random also generates from the math, so we have to like define it as math.random, and here we have to we want to have 2 pi. Hmm, hmm, yes, so we can have the theta value, I think, like that. So we are getting random theta values over here, and now what we can do is, in order to draw those particles are like circles. So we have to get the center point of them. So this center point should be calculated using this theta. Like as I have done this calculation for the x and y coordinate. So let's generate the x and y coordinates over here. It will be radius. Let's remove this one we have that we had defined for the circles. We are now doing generative art, and let's define a radius over here, and let's have the radius to be 200 again. And I have just taken it as double as we will be doing calculations of doubles. So what we can do is radius multiplied by cos component. You can get the cos from math, and we have to pass the radians, like we can pass here the theta, and in that manner we can also generate the dy component of that. Radius math sine theta. So we have the x and y coordinates. So we can like get the point. Um, so this is basically the center point of each particles, and we have calculated in a manner that it like covers the circumference of the circle. So now what we can do is we can use that canvas again and draw these circles. Draw circle, pass the position here. The radius is alright, and I guess this should draw the circles. Mm, let's rebuild it and see. We had given it radius, so it shouldn't be the radius. The size of the circle should be the particle size. So we can have it as we have the particle object over here, so we can get the size from it. Yep. Okay, so this again takes the double. So let's make this
How did this
random
happen?
size as
Half
double.
of the circle is visible from the top of the screen.
Yeah, actually that happened because the circle size is actually the total radius. Like we are creating 100 circles of 200 radius and they are centered on 0, comma 0. So this is what it creates. And so in order to fix it, like we have to use the particle size, like what we have created here, the random particle size. And what I figured out is we have to use double here as it takes a double. So next double and just generate from 0.0 to 1.0, so it's multiplied by 20, and again this has to be double. Okay, um you can see like we have got a particles across the circumference, but it's centered on 0, comma 0. So actually what is happening is um, this x and y coordinate is actually being calculated from the 0, comma 0 as the center. So the main circle is centered across 0, comma 0. So we can fix it easily by like adding that uh,
Center coordinates.
yeah, the center point coordinates. So x should be size dot width by 2 and this should be size dot height by 2. Think this should fix. Yeah, so we have finally got a circle
Woo!
and we
Something.
and yeah, so we have finally generated the particles and we have also placed it on a circumference of the circle, and we had also like generated random colors for each particle and we can use that over here. So in order to use that we have to define it in the paint color. So let's create this paint brush object inside this uh, each of the particle list, and let's pass the color from the particle object. So we can get the color from here. Let's see. Yeah,
Oh.
so we have got particles of different colors now. Hmm. So this is currently generating 100 particles. We can like reduce it as well. Like let's make it 50 and see what happens.
It's gonna be
Just have to
random
reload
every
for that.
time, so you can keep running it and keep it different. Yeah, so it's different every
Uh,
time you run it.
let's make it 10 and see what it generates.
Let's make it 100 and see what it generates.
Yeah, with 100, it was. We have to like every time we have to do the hot restart because like we are creating inside the init state. So if we like hot reload, this init state doesn't get called as the screen has already been built and Flutter takes the part which is uh, which is inside this build method. So anything outside of the build method is not called. So every time we have to hot restart that. Yes, so with 100, this is the particle. We can make it 1000.
Yeah, let's see with that. Oh,
Yeah,
wait.
1000.
How is
This
it
is a lot messy.
inside? How is the thing inside? Oh, that's the number of particles. Okay, okay. That's not the size. Okay. Fine. Nice. It looks really colorful. It's nice. Like we can have rings of these colorful stuff and it will be some nice design.
Yeah, what I am thinking is we can do like circles of different radius and
Yeah.
place particles across them.
Yeah.
So for that, let's keep the number of particles to 100. And now what we have to do, like mm, we have to vary the radius and
But then you want to fill the whole screen, right?
mm, like I want to create circles of various radius and place them across the circumference. So we have to randomize this radius as well. So where we can do that?
No. I mean, you don't need to randomize the radius, like just a loop, I guess.
Yeah, we can just randomize the radius over here. Let's not define it here. Um, let's vary between, no, radius is, hmm, make it 200. So this will vary from like 0 0.0 to 200.0. So this will take 0 radius as well. So let's not make that. Let's keep the minimum radius to be 20, and this will generate from 20 to 220 between them, the radius. I think this should do it. Let's, yeah.
Ah, nice.
Mm, yeah, it's actually it's not understandable from here, but it's actually like on different circles, the particles. We can increase the number of particles and see. Yeah, you can see that um, each of the particles are like on a circle, on the main circle, which is invisible for now. And yeah, it actually looks quite interesting right now.
Yeah. I like the previous version a little more.
And
Like, it was a bit clean. This is nice too.
yeah, actually for like making those nice patterns, we have to use some good formulas for that and generate them. Um,
Yeah.
Now we can make it more interesting by animating this.
Oh,
Mm, we can, like here you can see these are like uh, images, but actually when Deven Joshi created this, these are actually animated things. So I guess he has a Dart pad with the entire code available. So if you run that, it's actually an animated using that formula. We can do something over here as well. So let's define an animation. Um, for animation, um, let's go to the Flutter docs for a bit, like how to create the animation. Flutter animation. I guess here is a nice thing over here. Yeah, so this is quite interesting in the documentation. Like this shows like what you have to change in order to animate an app. Like this is for a basic animation for I don't remember, for animating something like I guess this width and height of a container, but we can use it to like generate particles in different points in our app as well. So first of all, you have to uh, use this single ticket provider mixin. So this home page state we can define, we can give it as with single ticket provider mixin, and mm, we can have this animation and the animation controller. And we have to initialize them. So this should be similar. So let's copy this part from here. Inside the init state, we are generating the particles, and let's copy it from here because I have a similar stuff on this article as well for animation. Um, yeah, so here I have like defined it a lot clearly. Like we have defined this animation controller, and let's define a twin. So actually, what this twin is, um, it is basically an interpolation. Like we are providing a beginning value and the end value, and it will interpolate between them. So we will like generate the animation using this twin. So this was rotation twin. So I think we can name it similarly. Like we will be like animating the particles so that it kind of rotates. So let's see. Okay, so we have to initialize the animation over here. So for that, I guess we can use this. Yeah, we can copy the whole part, I guess. Let's see. Yeah, so first of all, we're defining the animation controller and setting the duration. Let's make it 8 seconds, the duration of the animation. And now here we are actually using that twin and using the animation controller to add a listener. So what this part will do is as the animation value changes, So this will rebuild the widget every time. So that's why we are using set state here, so that it rebuilds. And we have already set this to a stateful widget, so it should be able to rebuild. And we have used this add status listener to like understand when the animation is completed or when it is dismissed. So as the status becomes animation completed, so we are using the controller to repeat the animation. And if the animation is dismissed, like after being repeated, it is dismissed. So as it is dismissed, we are using the controller forward. So what forward is, like it plays the animation basically. And uh, we are doing this because we want to repeat this animation for infinite number of times. Hmm. Okay, so we have the controller, and here it is generating the values from, let's generate the values from 0 to 2 pi. And mm, and let's pass this value to this painter so that it can use it to paint the particles in different points. So in the my painter, let's um, final double, let's define it as theta. We can animate it uh, like we will be like taking each of the circles and we'll be animating each particle on that circle with different theta values. So it will be like each of the particles rotating across the circumference of a circle. So let's see if we can achieve that. Require theta. We can pass this. So here we will basically pass the value which is generated by this animation. So we can use this animation object to get this value. So now we have this animated theta value, and mm, so let's change this theta to random theta, and we will pass it over here. And what we can do is mm, instead of doing this, we can, I guess, pass the theta over here. Hmm, I guess this should do the animation, right? Hmm, what we are doing is basically we are getting random theta values and drawing the particles. I don't know, let's rebuild the app and see what's. Oh,
No, something is happening. Okay, so it's building in a certain part of the. Oh, okay. So the whole thing is going to get covered now.
Hmm,
Oh no, it's completely
what it is doing actually is we had set this theta to be between this 0 and 2 pi value. So this is actually like building the circles from uh, like it is starting all the points from a
angle,
single
like a certain.
position, and yeah, like it's following a path and like building this, but you can see that it's flickering.
Yeah, I
Hmm,
mean, don't you think like it's increasing from 0 to 2 pi, which is like it's starting from.
no, I guess the circle rotation is all right. It's because of that value, but this it's flickering because I think uh,
Flickering is
we
fine.
are like creating these random values inside this. So it's rebuilding every time. So it's like flickering.
Yeah, but
So
then
how
it's
we can
between
fix
a,
that?
it's in an angle. Oh, it's flickering instead of rotating.
It's doing both actually. It's flickering and rotate. Um, but I think we shouldn't do that. Like,
Yeah, we should
um,
freeze it.
this will take a lot of memory of the app, and if we increase the particle, I guess this might hang up the app. Um, okay, I think I understand what the problem is. Like, we are generating this math random for each particle. So this is causing a rebuild of the widget, and then we are again rebuilding using set state. So this is causing two rebuilds at the same time. Like that is what is causing the flickering, I guess. So we can do it like this then. Um, let's go to this particle and modify it a bit so that we can store some more stuff here so that we don't need to generate it inside that loop. So mm, I guess we can have this starting theta, this radius as well. Mm, now let's see what we can do. So what we're currently doing is we have defined the twin here. Mm, let's define this part inside another method over here, so it will be more cleaner. Generate list of particles, and this entire for loop number of particles. Let's keep it here.
For
Yeah,
TX and
so
DY. Where is that?
mm, this this
Just
ran
just make it like okay, you're not passing. Just make it theta. Like multiplies and
mm, yeah, we can do that. Just a second. We have um let's do a bit refactoring and then let's check that. Like um we are generating the random size here, random color here, and let's generate this random radius of the circle also there. So like we can't keep any random object inside this, so this is causing the flickering, I guess. Let's try to solve that first. Um, Random radius. Mm, let's remove this 20 also. Let's keep it like this. Mm, and also generate the random theta over here. So let's get this theta. Random theta. Here let's make it 2 pi, and let's pass them inside this particle. Let's pass the radius as the random radius and the theta, the starting theta. Like we're defining the starting theta position here so that it doesn't uh, generate random values while it is starting. So random theta. And we have to call this method inside the init state. Mm, Now what we can do is inside the my painter. So let's modify a bit. Mm, we have two more properties inside the particle. Like mm, let's get those values over here. Uh, Random theta from the particle, starting theta, and let's multiply with that theta value, and also the radius we can get here, double radius particle radius, and mm, let's not define the paint over here. Let's um, keep it outside of this. Let's not define the color here. um, I think let's set the stroke width to 5 for now, and here we can set the color of that paint. paint color as okay, so let's rebuild it and see what's going on now. Oh, yeah, you can see that now the flickering is fixed.
Yeah.
Mm, but what it is happening is it's ending at a point and then it's again starting from the beginning position of the animation.
Yeah.
Um, it's because we have used controller.repeat. So in a instead of repeat, we can also use reverse over here. I guess let's see what happens now. Okay, you can see that, yeah, so this reverse after a point. We can do one more thing, like just a last bit. What we can do is, let's go to this my painter class, and here we are like multiplying the theta with the starting theta. I guess instead of doing that, if we add this, um, I think this what it will do is like it will increase the radius of all the circles and then decrease it. Let's see what it does by rebuilding. Mm, it's not doing that. Let's see what we have done for the last time and if we can achieve that like increasing circle kind of thing. So we have defined the number of particles. Inside the for loop, we have generated random size, random color, random radius, and a random theta. Okay, we have added the particle. And we are doing the animation for I guess we can define the twin over here. And mm, we have passed the particle and the theta over here. It's all right. Yeah, so for increasing that, what we can do is multiply this radius with theta as well. Um, so I guess this part will increase the size of the circle. Because we are multiplying with this after that. Let's see. Let's multiply both with theta and try for the last time. Rebuild. Yeah, yeah, this is what I wanted to achieve. And Let's increase this number of particles to 1000 and see.
Get a paper screen. Ooh, wow.
Yeah,
This is cool.
yeah, it really looks cool.
Yeah. So
And
how do you download these? I mean, apart from being a really nice animation, this is also a really cool piece of art, I guess.
yeah, uh, I guess you can also run it on the web and take a video out of it and
Oh,
like keep it as an animation.
yeah.
Yeah, so it's a Flutter app, so it can run on web, Mac OS, anything. Like currently we're running on iPhone, but it can run on any platform. So I guess for it, um,
It's really cool.
yeah. So for today, let's end it over here, and we can continue with this on the next episode as well of this generative art, and let's see what interesting thing we can achieve in the next episode.
Thank you for joining, guys, and hope you enjoyed today's session. I will put the link to this code on GitHub and put it in the video description. And please like this video and subscribe to this channel to get notifications for the next one. And in the next episode, we will also continue with the generative art and make it even better. So stay tuned for that. Thank you for joining today.
Thank you.